In this lesson, lesson 2.g, we're going to learn how to handle exceptions with try and catch statements. Now, errors do happen. Sometimes we make a mistake when we write our code. We put a semicolon in the wrong place, we type a variable wrong, we forget what the name of a variable is, and so on. Those get caught when we write the program. Our compiler, Eclipse, tells us, I'm sorry, I don't know what this variable means. Those compile time errors are taken care of before our users ever execute our programs. But sometimes errors happen after we've compiled the program and somebody is running it. Those are called runtime errors. Well, here's an example. Suppose you wanted somebody to type in a numeric value and they accidentally hit the letter T instead. They wanted to type in a 5 and their finger just missed and they typed in a T. So look at this code. This would be like we did in lesson 1. We had a scanner called console that's hooked up to system input. Print out, enter a number, and then we said, give me an int variable called entry that consists of console.nextInt. Now, the scanner has many things I can do: next, next line, next double, next int. Suppose I said, give me the next integer because I want to put it in a variable called entry. This is perfectly legal to do as long as the user types in an integer. But suppose they miss the 5 key and they hit a T instead. What's going to happen? They'll get this sort of message. You'll see it in your console window in Eclipse. But if they're running the program outside of Eclipse, the program will terminate with an input mismatch exception. And that's going to mean absolutely nothing to your end user. What it means is your program knew that you needed an integer, but it didn't have an integer. So it didn't know what to do. It just terminated. It ended without finishing your code. We don't ever want to see that stuff. So let's see what we can do to avoid that. You might be able to anticipate the type of errors that a user would commit. If you do that, you can put the statements that might contain an error inside a try block. Here I've got the same statements that I had before. Scanner console is a new scanner. Print out, enter a number, and then the line that might cause problems. Int entry equals console.nextInt. But notice I have now enclosed it inside a block of code. It's got the braces that has the word try in front of it. So all of the statements in the try block get executed, and then immediately after the try block, I have a catch block. And the catch block says, if this thing happened and you were going to terminate the program, don't terminate the program, please, Java. Do what I tell you instead. So maybe you'd print out, bad input, buddy. Instead of terminating, you give them a message that says, hey, you typed something in wrong. And in your code, maybe you're inside a loop, you go back and you ask them again. Now, what do we have here inside the catch block? Catch has a clause inside parentheses. It's the name of the exception, input mismatch exception, then a variable that you're going to give it. I just used the letter E for exception. I could use any valid variable name here. I could call it E, I could call it F, I could call it my silly input mismatch exception, whatever I want to call it. I'm just calling it E here to make my code a little bit shorter so I can type it all in one line. It says, catch an input mismatch exception. If that happens, put all the information about the input mismatch exception into the variable E. Then execute the code between the braces, which is just going to write out bad input, buddy. So here's the syntax of the try and catch statements. Try, and then a block of statements inside braces, any statements that might throw an exception. Then catch, the name of the first exception with a variable name. Here I used E. I can use any variable I want. And the statements that you're going to do to recover from the error. Then when you close that catch block, you can have another catch block if you want. The name of another exception and a variable. I used E again. I don't have to use E. I can use a different variable for each one. I can use the same variable, completely up to me, as long as it's a valid variable name. And then the statements to recover from that error. I can have any number of catch statements that I want. Now, what are some of the exceptions you might see? Input mismatch exception, null pointer exception. You're going to get that a lot in coming weeks. We haven't done anything yet where that can happen, but as soon as we start working with classes, we're going to have null pointer exceptions. Index out of bound exception, you haven't had a chance to make that error yet. It's coming up when we do arrays. It's quite possible to get an index out of bounds exception. File not found exception. Let's say you're trying to open a file and read something from it. We haven't done that yet, but when we do, we might get a file not found exception. You could get an arithmetic exception, like dividing by 0. Or you could get a generic exception. There's a hierarchy of these. Exception includes all of the others. So let's say I wanted to do multiple exceptions. If I catch more than one exception, I need to handle the ones that are more specific first, then the more general ones. So look at this code. Try, and then some statements that might throw an exception. Now suppose I do catch exception and give it a variable E1. In my catch block, this catches all exceptions because the exception EXCEPTION is the most generic of all. An input mismatch exception is a type of exception. An arithmetic exception is a type of exception. So this will catch all exceptions. What am I doing here? Well, here's an example of where I'm actually using the variable. In this case, E1. E1's an exception. I type in E1.getMessage, and it will tell me whatever that exception's error message was. So maybe I want to do that as a generic. If I didn't handle it for some other reason, just print out what the system would have done. And then after that, I put catch input mismatch exception E2. This is bad code. Java will allow it, but this block will never get executed because every exception will get handled by the first catch block, and you'll never handle your input mismatch exception. What should you do? Move the last 3 lines up above the previous catch. If you move the last 3 lines so it's the first catch block, this will do exactly what you want. Now, what can you do with exceptions? What are you going to do with exceptions? You're going to notice that in programming assignment 4 that you're going to be starting to work on, called the logic game of NIM, you're asked to make sure that the program doesn't terminate with a runtime exception if the user enters non-integer values. You're going to be asking the user, how many sticks do you want to pick up? And they're supposed to enter 1, 2, or 3. If they accidentally hit a T or an R or something that's not numeric, you don't want the program to terminate with some silly Java error message. You want to tell the user, nope, that's not the right thing, try again. So you're going to have to figure out how to use try and catch statements in a loop somehow, so that when they enter something invalid, they're told about it and they get another chance. Okay, this was the last of our lesson videos for lesson 2. If you got all that information, go ahead and try the Are You Ready quiz, and you should be ready to start programming assignment 3 and programming assignment 4. Remember to be working with your partner to check with them, see how things are going. Don't let anybody fall behind. Make sure you get your second and third video posted into your wiki project. And as always, if you're having issues, join in my weekly office hours, post something to the general discussion database, ask a friend in the class, ask a friend not in the class, send me an email. We don't want you to be stuck for too long. So go ahead and get started. Enjoy yourself. I think you'll like these 2 programming assignments.